Let's talk a bit about unsupervised learning next. Again, in unsupervised learning, you have broadly several different types of unsupervised learning. One type which I will focus for this course is clustering, which means that again, if you recall, unsupervised learning is where the labels are not given, it's only the features that are given to you. And then what we want to do is we want to meaningfully cluster these or group these features into different groups, right? So let's say I have 1,000 data points, and then I want to say, some points correspond to group 1, some points correspond to group 2, and some points to group 3. And now I want to do this automatically. And how can I do that? Maybe I will look at which points are close to each other, and then I want to think of them as being part of one group, right? So roughly speaking, right? So semantically, whatever groups objects or data points in a meaningful way, we want to do that, right? So when we do that, it's a problem of clustering, and we will see in detail one example of clustering as we go along. So I won't talk so much more about clustering now. Representation learning is another interesting aspect of unsupervised learning, where we want to learn meaningful representation from data. The data could be images, but then we want to say, how can you compare two different images? For example, two images which are, let's say an image like this of a person like this, and there might be another image of the same person in shifted, right? So maybe there is a rotation of this of image. There is the same person, but then the person has moved by 45 degrees or 90 degrees to his right, his or her right, and now I want to treat these two images as the same, right? So but then if you just measure distance between these images, raw images, they may not necessarily be close to each other, because these two images as images look differently in terms of their pixel values, but we still, as human beings, we think of these two as the same images, right? So it's because it's the same person, just that the camera angle is different. Now, can we learn some representations of these images such that in this new representation, even though the person is turning in whatever direction, the representation that we learn is agnostic to this, right? So in this new representation, these two images will still be close to each other. And that is important because, later on, if we want to use this representation to do some supervised learning, then it is good if all the images which are go to similar representations, irrespective of the orientation in which the photo was taken, the scale of the photo. I mean, maybe I kind of zoomed in a bit on one image, right? So maybe there is another image of the same person, but then this time it's a zoomed version. I still want to think of these two as images as the same images, because let's say I want to later think of this as doing supervised learning later, where you want to use the features to say whether a particular image corresponds to a person who belongs to a particular company, or who does not belong to a particular company. Maybe you install a camera in front of your company, and then the person stands in front of the camera clicks, and then you want to detect whether this person is part of the company or not. If so, then you will let that person in, otherwise you won't let that person in. Now, depending on where the person stands, right? So I mean, maybe the person stands 1 feet away or half a feet away, you are going to get close-up images or slightly further apart images. And now, it should not really matter the small differences in where that person stands in figuring out whether that person is part of the company or not, because it's the same person, just that he or she is standing a little bit further apart or close by to the camera. So which means that you want to learn some way to represent these images which are distance agnostic, at least up to a certain level, right? So and how can you do that in an unsupervised way is what is called as the idea of representation learning. Again, it's a fascinating area, but we won't really dwell deeper into that in this particular course. I just want to give a high level view of that. In sequential learning, there are three different major types: online learning, bandits, and reinforcement learning. In this module, I am not going to talk about this right now, because there is a separate module later on in this course where we will talk about these three different types of learning, and then I will give you different examples and try to illustrate what is the fundamental difference between these three types of sequential learning. At this point, I just want to put out that there are all these different types of learning which are fascinating, and they have tremendous application. I mean, I've given you a lot of real world application already,